Good morning. Thank you all for coming along here. I am Bruce Grover. I'm the CEO and co-founder of Polystream. And I'm here to talk a little bit about cloud gaming and how Polystream is rethinking how we need to reinvent the internet, how we need to really design it if we want to actually make cloud gaming the vision that everybody has for it. So we believe that all digital content should be streamed. We believe that what we have seen with music, what we have seen with media, should be just as available to games, interactive entertainment, and high-end applications as it is for all the other kind of content that we have today. Over the last 15 years, we've seen a lot of push into interactive entertainment, into cloud gaming. We've seen the early pioneers of cloud gaming come along, make a big impact, talk a lot about how they're really going to change the world, how they're going to be the last console you will ever see. But one of the things you'll notice is all of the names that were part of that first wave of cloud gaming aren't here anymore. And so one of the challenges is, what is it going to take for us to really break the back of how do we produce cloud gaming? How do we make it what we want? And so Polystream believes we need to completely rethink how we do it. Streaming's coming back again. We're seeing all of the big names talking about it. We've got Google, we've got Microsoft with xCloud. We've got the big game publishers like Ubisoft coming in and saying, we want to be part of this. We want to deliver our games. Square Enix doing trials all around the world. We're seeing not just small games, but big games and big franchises really thinking about the future. But we're not there yet. We're still hitting some of the same challenges. We're still making a lot of the mistakes that people have made before when they go out to build a cloud gaming solution. If we take latency, everyone likes to say latency, lag, as one of the problems. Let's take that one apart a bit. The first thing that creates latency is your controller. When you're using your controller, your keyboard, your mouse, you're looking at 2 to 3 frames of input. Your game pipeline. We've seen games like Street Fighter talk about how they're happy to get from 9 frames down to 6 frames in the game pipeline. We're talking about adding nearly 100 milliseconds of latency in some cases. High-end games, depending how they've been optimized, maybe 2 or 3 frames, but we're still talking 32 to 96 milliseconds. Then we get to the crux of how do you do cloud gaming. You're encoding it into video. Typically, you're doing that in about 8 milliseconds now. It's a very small chunk of time. It's done in the GPU, it's very rapid, and it's all done as part of the pipeline of cloud gaming. And if you have a good ISP, if you have a good broadband connection, you're looking at somewhere typically around 20 milliseconds for latency on your network to the data center. This is the latency that you have to the edge. Where most people start to see problems is when they're trying to connect to a cloud gaming server that isn't close to them. And also if their home network isn't very good. Now we start to see problems with your in-home Wi-Fi where you can be adding far more. But now your cloud gaming has to be decoded. It's another few milliseconds. It's done on your local device. And it's decoded in exactly the same way that we decode something like Netflix or decode something like Amazon Prime. It's just video. It's easy. Your machines can do that very quickly. And then we have your display. Your display can add a huge amount of latency. A high-end gaming monitor might be running at around about 4 to 8 milliseconds of refresh, but a nice TV with all of its features turned on and its smoothing and its color correction, you can easily see 80, 90 milliseconds in the pipeline there. When you see some of these machines, some of these TVs saying they're turning them to game mode, that's not even consistent as to what they do. Some of them will just turn up the contrast and the brightness, while others will actually turn off a lot of those additional features. So you don't even know what you're getting when you talk about things like turn on game mode. So here we have a pipeline, 180 milliseconds end to end. For most people, that's still going to provide a perfectly acceptable gaming experience, particularly on most games. We're not talking about the highest end of Twitch games. We're not talking about esports here, but we are talking about how does the mass market want to consume games. And we'll notice from that, it really isn't about encoding and decoding. It's about all of the other pieces in the pipeline. The problem is the cost of operation. It's never really been about the latency. The latency's only ever been a symptom. Today, we take a high-end gaming experience, we take a console, and we build it into a server. Sony puts PlayStations in the cloud. Microsoft is talking about xCloud as building Xboxes into racks in servers. And you then decode that, you then encode that into video. You're giving people a compressed video experience. But really, think about the cost of running at capacity for millions and millions of players around the world if every single one of them needs their own console in the cloud. If I say I want to run a PlayStation in the cloud, we've just been looking at Resident Evil. Resident Evil launched a demo a couple of weeks ago. 2.5 million people have played that. Think about how many consoles in the cloud you now need to play that game. And that costs you power. It costs you dollars per hour per user. And that cost just becomes unsustainable. How do I build a service? How do I build a subscription service? How do I build a premium service? How do I create an experience for 3.4 million concurrent Fortnite players from the cloud if I need 3.4 million consoles in the cloud? That isn't a sustainable model if it's built on something that is just moving the problem from one place. At Polystream, we've thought about the problem differently. We're looking at the internet, we're looking at the next generation of internet. We're looking at all of the pieces. The internet is a distributed piece of architecture. Everything from the edge to the servers to the storage to the device in your hands all have a place to play in this. We don't want to ship you encoded video because you've actually got a GPU on your device. Whether it's your console, your PC, it's your phone, why wouldn't we tell that what to draw? It's the thing that's going to give you a high-res experience. It's the thing that's going to give you the highest quality. So at Polystream, we're running the game engines in the cloud. We're thinking about the edge as a place to place other parts of the game. We're thinking about your device for rendering the game. Your device is the thing that's mated your graphics processor to your screen. So that's what's going to give you pixel perfect, the colors the game designer created. We're going to give you the game as it was meant to be. So instead of shipping you video, we're shipping you data. We're shipping you data that tells your device what to draw. We don't want to put the game console in the cloud. We don't want to just move the problem from one place to another. It doesn't matter if you're Google or if you're a small startup trying to build the next generation of cloud gaming. If all you're doing is moving the gaming machine to another place, it doesn't matter how much money you have, if you cannot make the business and the cost of operation work. The cost of operation has to work for the user if you want to build a subscription service, has to work for the publisher if you want to make it operate at a scale that actually means that they can ship millions of games and they can have people playing for hundreds of thousands of hours. If they want to make that work, then we need to think about the cloud as the console, not just putting a console in the cloud. We're moving to super fast broadband. What does that mean? Well, people keep talking about 5G. What is 5G? 5G is not just a faster broadband pipe. That's what it's going to start at, but actually it's a completely new architecture. It's a completely different way of building the internet. We're going to see the edge take more, have more part to play. We're going to see more devices connecting locally to other devices. Today, a typical phone tower can connect a couple of hundred devices together. When we move to 5G, that's going to be starting at 10,000 devices, all having access to gigabit speeds. Their latency is going to be sub 4 milliseconds to connect to that. For years, we've talked about fiber to the home, fiber to the curb. Now we're talking about fiber to the post. We're talking about all of your mobile connections being as good as having a fiber broadband connection. And as this rolls out, we're going to see people thinking differently about how to use the distributed internet. We want to be able to put the game wherever you need it to be. We don't want to always be pushing it to the furthest point. When we always went back to the early days of cloud gaming and talked about latency, latency was distance because we couldn't afford to put the game in every data center. We couldn't afford to build servers as if they were consoles and fill the cloud with them. So in a Polystream world, Polystream's the connector. Polystream is here to build all of the pieces that glue all of the different parts of the gaming experience together to create what will truly be a scalable gaming solution so that we can now think about cloud gaming as an actual way, a viable way of reaching hundreds of millions of people all around the world. When you hear the big three talking about building a cloud gaming solution, all of them have a footprint. Their footprint is growing, but this is a very common cloud public provider. This is one of the largest in the world. And you'll notice their footprint is still very limited. If I want to reach the west coast of Australia, I'm 3,000 kilometers away from the nearest data center. Well, that's latency. That's where your latency comes from. If I want to reach Hawaii, well, there's a submarine cable that can take me to California. And that submarine cable is several thousand kilometers. I don't have a footprint that enables me, no matter which of the big providers I am, to really give a global cloud gaming solution. PlayStation Now has been running for about 4 years, and they still only have 4 or 5 data center deployments around the world. They're still limited to a handful of deployments in Europe and the US. And they've been doing this for quite a while now. This isn't because they don't have the expertise. This is because they can't make the cost work. You simply can't afford to populate every data center in the world with cloud gaming. But Polystream can, because Polystream is just using the cloud that's already there. We're not creating new hardware. We're not putting consoles in the cloud. We're using the cloud wherever it is. We're using the CPUs, the memory, the storage, and we're using your GPUs. We're using the edge. We're using the networks. This is how you solve latency. This is how you solve cost. And this is how you solve scale. You do it by using utility compute. You do it by using elastic compute on demand. And you do it by building it close to where the users are. If I want to stream to you in Hawaii, Hawaii has a cloud there. There are infrastructure there. If I want to stream to Brisbane, there's infrastructure in Brisbane. We can already stand up cloud wherever we need it in the world. And that population will, that density of data centers will continue to grow. And we see great things in what public cloud is doing, not cloud gaming, but public cloud. We see Microsoft and Amazon talking about how they're going to populate all around Africa. We see the growth wherever there is population density, but then it spreads out. And then we see next generation network technologies like 5G acting as the connector for all of those. So ultimately, for Polystream, what we want to be is the connector behind all of these cloud gaming companies. We're a SaaS platform, we're a B2B, and everyone that wants to do cloud gaming at scale is going to want to be able to connect to any data center anywhere in the world, to any gamer anywhere in the world, over any network anywhere in the world. And to do that, you're going to be looking at Polystream, and you're going to be looking at streaming to your device to let your device be the gaming device. We're going to make the cloud the game console, not just push it away again. That's Polystream. Thank you.
So we have time for a couple of questions. If anyone has any, I'm going to hand you the mic. Anyone?
So you say the GPU still has to process that data and then put it onto the screen. How powerful a GPU is required in order to do that on a device?
Yep. That's one of the first questions we often get asked. And so one of the things that I think we look at is we always look back when we're thinking about some of these technical challenges. People go, I need a big GPU to render the game at 4K so I can stream it over an 80 megabit connection. And instead, we want to think about it differently and think about, well, actually, if we want to build it at scale, how do we start thinking about our devices as well? Not just the fact that we want to make all of these devices rendering, but what do we think about if I can run an application from the cloud? Do I build a netbook differently? Do I put a more powerful GPU in a netbook so that I can now remote my applications? Do I look at, when people talk about building low-end consoles, when we talk about diskless Xboxes. That Xbox still has a GPU in it. It's a perfect streaming device, but I now don't have to fill it with as much storage. I don't now have to give it as much memory. I don't even have to make the CPU as powerful. So I can rebalance, I can refactor some of my hardware. If I want to give a 4K streaming experience as a game, then we're talking about 80 megabits a second of bandwidth. And again, that's part of the unsustainable problem. If instead what we're doing is we're sending draw commands, we're sending data to your GPU, that's much lower bandwidth. That can be compressed more easily, and now we can send 4K as 20 megabits. So it's about this whole idea of distributed internet. Every piece has a piece to play. I want the edge caches to do more. I don't want to run a game remotely and then send it all the way down to this device. I want the edge to have a part to play in this. I want the compute to be where I can build infinite game engines and infinite physics. I want the GPU to be able to render at whatever resolution, and that's best done locally on the GPU. So we can't make a GPU faster, but what we can do is ease the burden on the rest of the machine and use the GPU now as a more powerful device. And think about architectures like speed boost on CPUs. What happens if we now have speed boost on GPUs? Because I can now take advantage of when I want to run a high-end application, I just put all of my compute resource over to drawing.
Thank you.
Right, we have a little bit more time if we have one more quick question. Go about 2 minutes for the next one.
Cool. So you mentioned 5G. To what extent is 5G necessary for you as a platform to sort of reach its full potential? And my second question, do you think 5G will already have a sort of effect on you and your platform this year or next year?
I think for us this year, there'll be very little impact from 5G, and I think that's probably true for the next couple of years anyway. Any new infrastructure like that's going to take time to roll out. But I think when we look at the sort of behind the sort of headlines of what 5G is, and we start to look at the architecture, and we think about what that's going to mean for everything from a telco operator to a CDN operator, everyone's going to be starting to rethink how they develop their networks, their infrastructure, and their architectures around that. And 5G will have an effect that then knocks back into fiber, knocks back into cable, and all of the other infrastructure. So one way to think about it is today, the edge is a fairly benign part of the internet. It's where we do switching, it's where we move data around, but we don't really do much more than that. If we step back a little bit from that, we have CDNs that are used for caching particular kinds of data. When we look at 5G, 5G is going to be starting to interconnect those things far more than they are today. We're going to start to see data being able to move sideways rather than just up to a server and back down. Today it's very much a messaging service, client to server and back again. And what we'll see is we'll see far more about each device being connected. Each device is now a node, and that will be from 5G, but it will have that same effect with everything from your fridge to your thermostat. And it will just accelerate that kind of thinking, and that in turn will lead into how do we develop applications for that environment? Where do I want my CDN to be now, and how do I want my CDN to perform? Do I want my CDN to perform as a 1-second buffer or as a 16 millisecond buffer, right? And if my CDN is now 10 milliseconds away from the endpoint, then it's far more usable for things like interactive gaming. So Hatch has already been doing some great work in streaming over 5G and testing that, and we're already seeing that the performance of the network meets that. Now we've got to see the architecture built out by the telcos, and some of that will also come from ensuring, for once, that the telcos will work together on this as standards, and that we develop it so that we have a common infrastructure and architecture, so that we as developers are creating the next generation of applications that just work seamlessly across all of these networks.